Hello, everybody. Welcome today. Thank you for joining us. Before we get started, could I just get a couple people to click on the raise hand button in the control panel so I can confirm that you can hear me clearly and that you can see the screen that says Future City on it? Great, thank you. Thank you very much. Well, welcome to the Future City Headquarters Ion Engineering webinar for 2019. This is our third year doing this series, and we're very happy to have you with us. My name is Jake Williams. I'm the program coordinator for the Future City competition, and also on the line is Future City's program manager, Maggie Dressel, and she's on the line to answer any questions that you have as we go along with the program. Before we get started, I just wanted to mention that the platform that we're using is GoToWebinar. And if the sound quality over your computer isn't great, there's a teleconference line that you can call into, which is often slightly higher quality than the computer. So if you're having any trouble hearing so far, you can call into this number. That number is also on your webinar control panel, and the access code is there. Also, as a reminder, a recording of this webinar is going to be posted on the futurecity.org resources page in a day or two. We'll also be emailing this out to everybody who signed up also in a day or two. If you're looking for webinars about specifics of the Future City competition itself, things like best practices and advice and recommendations about the deliverables, that you can check out our two recent educator webinars. And for background on this year's challenge, which is good for the whole team, you can check out our Clean Water Tap into Tomorrow theme webinar. All three of those webinar recordings are available in the resources page of futurecity.org. As I mentioned before, feel free to type in any questions as we go. Maggie will be collecting them, and then we'll direct them to the panelists, to the speakers at the end of the webinar, and we'll have them answer as many as we can get to. Also, just as a reminder, make sure that you direct your questions to the speakers themselves. If you have any general questions about the Future City program, most of those answers can be found in the program handbook. And if you don't find them there, you can email info, I-N-F-O, at futurecity.org, and we'll be happy to answer them. Now to get started, when I was in 8th grade, I participated in the Future City competition. My team and I, we created the city in Montreal, Canada. It had smart sidewalks and an underground bubble tube for transportation, which for the record now, 17 years later, I'm still waiting for bubbles to be a publicly available form of transportation. I'm sort of disappointed that it hasn't happened yet. But until I did Future City, I didn't really have a clear idea of what engineers or technicians or technologists or mathematicians typically did day to day. And though I could probably name a few different types of engineers and STEM professionals, I didn't really have an idea of just how many different kinds that there actually were out there. So today, we get to hear from three exciting STEM professionals about what they do. Each presenter represents an organization that sponsors a special award at the Future City Finals competition. Both Future City Finals and the regional competitions have different special awards that teams are eligible for. So you can check with your regional coordinator to find out what specific special awards are offered at your local competition. And one thing to keep in mind is that the point of the special awards is not just winning, but it's a way to dive into a specific technical field and learn more about it. That's why today we have professionals from these three different groups to talk a bit about the work that they do. And when the webinar is over, I think that you'll have at least a few ideas about things to pursue or explore for your Future City project, and you might develop some new interests for even beyond Future City as well. So you don't need to listen to me talk much longer. So let's get right into introducing our guest speakers. Joining us is Jennifer Warner-Heyman from the Institute of Transportation Engineers, Andrew Sargent from the American Society of Landscape Architects, and Diane Haithcock from Underwriters Laboratories. Our first speaker is Jennifer Warner-Heyman from the Institute of Transportation Engineers, or ITE. She has lived in many different states throughout her life, including Texas, Idaho, Georgia, Oregon, and currently lives and works in Harrisburg, Pennsylvania. She has a Bachelor's of Science in Civil Engineering from Southern Methodist University in Dallas, Texas, and a Master's of Science in Civil Engineering from Oregon State University. During her career, Jennifer has interned for the Federal Highway Administration, conducted research at Oregon State University, and worked for multiple private engineering companies. This past spring, she's earned her license as a certified professional engineer. Congrats. And today, Jennifer is going to tell us all about what transportation engineers do and share a bit about the organization that she represents. So Jennifer, welcome.
Thank you so much, Jake. Really appreciate it. You can go ahead and go to the next slide. We'll just dive right in. So hello, everybody. As Jake said, my name is Jennifer Warner Heyman, and I'm here today because I love my career as a transportation and traffic engineer, and I can't wait to tell you more about it. So how did I get into an engineering career? Next slide, please. So I have always loved math, science, and problem solving. So in elementary and middle school, I would participate in fun STEM summer and after-school programs, sort of like Future City. Go ahead and hit next. So there's me as a kindergartner about to launch my very first bottle rocket, and then continued this interest into high school where I took advanced math and science classes, and then continued in college. I went and I studied civil engineering, and now I work as a transportation and traffic engineer, and a job that I absolutely love and feel so lucky to get to do every day. So what is transportation engineering? I'm going to start with the basics here of what is transportation. Next slide, please. So transportation in a nutshell is just traveling from one place to another, or the movement of people and goods. And I'm going to say, don't believe the hype. A lot of people think that transportation is just about cars, but that's not true. And to illustrate this, I'm going to ask you all a question. Next slide, please. So how did you and your classmates travel to school today? You may have been driven in a car, or you may have gotten on a bus and been driven to school, or maybe you rode your bike or walked to school or took a train. It's unlikely you flew, but maybe if you're in a regional area, you may have done that, or perhaps rode a ferry to school. So there's lots of different ways you may have traveled. And next slide, please. And we call all those different types of travel multimodal transportation. So multimodal, that's kind of a big word, right? I'm going to dig into that a little bit to sort of help you understand what we're talking about there. Next slide, please. So if we break down the word multimodal, multi meaning more than one, many or different, modal meaning methods, forms, and types, and then we add that in front of transportation, we get multimodal transportation, which is many different methods of traveling from one place to another. So just like we talked about, there's all those different ways of traveling around. You've got cars and buses and bikes, walking, trains, and more. So all of these different ways of traveling, next slide please, have different infrastructure needs. And when I say infrastructure, I'm just talking about the physical things that they need in order to go. So if we're talking about cars, they might need roads and traffic signals and parking lots. If we're saying buses, they might need bus stops. Bikes need bike lanes or bike paths. People walking might need sidewalks and crosswalks. And you probably see all of these things out in the world every single day and never have really thought about that somebody's out there designing those things. So the different types of travel that are in the blue box are generally the different types that I work with. There are many, many transportation professionals that do all the different types, but those four at the top are the ones that I generally focus on. Next slide, please. So I think about how the car infrastructure and the sidewalk infrastructure and the bike infrastructure and all of it relates together. I think about the connections between them. And I want to make sure that traveling is safe and efficient for all of those different types of transportation. Next slide, please. So here's a picture of an intersection. You probably have seen this out in the world quite a bit, and some of the different pieces of infrastructure that are out there are labeled in this picture. So we've got traffic signs, we have a traffic signal, we have what's called a buffered bike lane, which just means there's space on either side of it. You can see the sidewalk and the crosswalk for the people walking, and then you've got the road and pavement down there. So as transportation engineers, we think about all of these different features and infrastructure and make sure that they're there for all those different types of travel. Next slide, please. And go ahead and advance all the way through. All right. So we've got, here's another example of a place where there were people crossing in the middle of the road, and we said, hey, that's not as safe as it could be, and we put in a raised crosswalk and some traffic signs to help say, hey, people are crossing here. And what's kind of neat about this is that as transportation and traffic engineers, we have lots of manuals that have been created that say all these different ways of putting different signs in, and they give you sort of rules for when you can and can't put them in. And that's all based on math and science and physics. So that's one of the manuals that's highlighted there. Next slide, please. Here's another example of a situation where we wanted to make the sidewalk a little bit better. You can see in that picture on the right that there is something blocking the sidewalk. Now, while it might be very easy for me to walk, step around it, somebody in a wheelchair might have a little more difficulty getting around that. So for this project, we recommended they take that out. Next slide, please. Another thing we talked about, if you're somebody walking or if you're rolling in a wheelchair or if you're a parent pushing a stroller, you might need to have what's called a curb ramp. And these curb ramps have science and math that goes into figuring out what the rules are for how you can design them. And so what the fun part is, as transportation engineers, you have to kind of figure out how we get all those rules to fit in different situations. So we use those to design different things. Next. We also talk about even a bigger scale. So those last couple slides were very granular, like on the street level. This is a picture from way high up in the sky of a highway interchange. And just like that other manual I was talking about, there's a whole manual that talks about how to design big roads like this. And there's the guidelines are based on research that's been done that uses physics and math and comes up with all these equations and rules, and they help to guide how we lay all of that out. Next. In addition to that, we have to think about, okay, what are the different types of vehicles that are going to be on there? We talked about, we care about multimodal transportation. It might be that a car is able to turn in a smaller amount of space than a big old truck, right? Might be a little bit harder for it to turn, and so we have to think about these kind of things. Next. And then if we talk about some other things we think about is stopping sight distance, which is we want to make sure everybody has enough, is able to see with enough time to be able to stop safely over a hill. Next. More than that even, we talk about work zones. So if you have construction out there on the roadway, transportation and traffic engineers lay out where all the barrels go, where the signs are, and we use our guidelines to do that. Next. In addition to the infrastructure and the work zones, we also look at traffic systems. So if, for example, we have 3 traffic signals in a row, we want to make sure that people are able to drive through them and not get caught in the middle, have 3 green lights in a row, to try to help people move quicker through them. Next. And we might play with, okay, what kind of lane configurations are there? If there's lots of people turning left, we might add in a left turn lane to more room. All right, next. So those are all just some of the things the transportation and traffic engineers think about. But you may be asking, what does a regular day look like for a transportation engineer? Next. So most of my days, I'm working inside at my office, at my computer, and next. And that might mean that I am writing reports or running data analysis. I might be sketching things out in my CAD program, or I might be using a 3D modeling software to model my designs. Next. And one of the things that we do is we create plans that map out what we want our construction teams to do. And I use my super cool professional engineer rubber stamp over there to basically say, I'm an engineer and I approve this message. Next. And then sometimes I even get to work outside of what we call going out in the field. So you'll see me there. I've got my hard hat, my vest, and my work boots, and that's all for safety. So that's all what my work is all about. And the very last thing I'm going to talk about here today is the organization that I'm here representing, ITE. So ITE originally, as the Institute of Transportation Engineers, was originally a group of mostly engineers, but now our community is made up of lots of different types of transportation professionals. We have engineers, planners, researchers, technologists, educators who all use math, science, and their expertise to make transportation better. So as an organization, ITE creates some of those guidebooks and manuals like I was talking about, and they provide technical trainings to make sure we all know the latest and greatest ways of doing things. And they support causes like greater focus on making sure that all those different types of transportation are considered and that safety is our highest priority. So I hope you've enjoyed learning about transportation and traffic engineering, and please let me know if you have any questions at the end of the presentation. Thank you so much.
Great. Thank you very much, Jennifer. That was excellent. Our next guest is Andrew Sargent. He is a landscape designer and innovative new member of the firm Lionheart team in Austin, Texas. Andrew's design sensibilities combined with his technical abilities have allowed him to pioneer the use of design technology for the field of landscape architecture. His technical proficiencies using various software has been instrumental in the coordination between multiple consultants and his internal design team. Andrew was the recent recipient of the Landscape Architecture Foundation's Fellowship for Innovation and Leadership and focuses his research on immersive technology's role in landscape architecture today and its effect on client and public engagement within the design process. Andrew, thank you for joining us today.
Thank you for having me. So, hey guys, I'm going to talk about what it means to be a landscape architect. And it's a bit of a understated profession. It has the word architect in there, but also landscape in front of that, which is really important. Next slide. So landscape architects do what? Make buildings, make trees, maybe make a little bit of trouble, but we don't make pizza. We actually make, next slide, places. And I'd ask you guys to take a moment and think about what a place actually is. What defines a place? So take a second and think about that. Next slide. So we design places that help fight climate change, environmental hazards, homelessness, and unsustainable development, and the list goes on. So the places that we design and help get built are places that have multiple functions and do a lot for society and do a lot for people in general. Next slide. These places, the most popular ones are parks. So within the public realm, we design a lot of public parks, and these are just some examples of public parks. Some of them are more famous than others. Of course, in the bottom middle row is Central Park, and I think you guys, or most people, know what Central Park is and where it is in New York City. And that was designed by the actual first landscape architect, Frederick Law Olmsted. And landscape architects have a rich tradition of designing public parks, really great public spaces that are used by everyone throughout the year. Next slide. So again, these parks range in size and all over the nation. So from Central Park, like I said, in New York City, Dilworth Park in Philadelphia, Maggie Daley Park. I know you guys probably are looking at that great playground there in Chicago, Clyde Warren Park in Houston, Mill River Park in Massachusetts, and Tongva Park in California. Next slide. But we design other places too, from waterfronts adjacent to rivers, lakes, and things like that, to museums, green roofs, which is something that's really new in the day that we live in. Repurposing the tops of buildings, or what you're seeing right here is a repurposed railroad track in the top right corner. Memorials, plazas, and even streets, some fancy streets like you see the one in the bottom right corner. Next slide. So how do landscape architects design these places? The profession has been around for a really long time, and conventionally we design with just drawing. We get out the trace paper, markers, pens, and things like that, and draw out plans, elevations, and pictures and perspectives, and show these to our clients in order to get buy-in for designs and then get those things built. But ultimately, moving forward in the year 2020 and beyond, we're using a lot more technology to design and embolden our design process. Next slide. So we work in teams, and you can see this is the typical layout of a landscape architect office. So you'll see there's going to be half computer space and then half drawing space. So as I said, as we're moving towards new technological processes, we still do a lot of drawing, and you'll see how that plays hand in hand in the profession now. Next slide. So the old to the new, you could see on the left-hand side is kind of your typical drawing from back in the day, a lot of sketch and marker and things like that. But now we're doing a lot of 3D modeling and drawings on the computer to do the same things that we did in the past in order to design the best spaces possible. Next slide. And we use all types of technology, like I said. We use modeling to show the slope and elevation in landforms. We use different types of visualization techniques to show planting and things like that. Fabrication, a lot of times we'll mock up a bench or some type of paving in-house and get actual builders to come in and fabricate those things before we implement them on a larger scale. And even animation, thinking about things like Pixar films and things like that. Sometimes we use animation to get our design ideas across. Next slide. Like previously mentioned in the little brief bio, I've been pioneering VR. That's me on the left wearing a VR headset in my office. And on the right is a class at Utah State University, which I taught over the summer for 1 week, teaching those kids how to create VR experiences with landscape designs that they designed during that time period. So VR is a brand new thing. Well, not necessarily a brand new thing, but a brand new thing to the profession. And it's important to us because a lot of the things that we think about when it regards to landscape, you know, the change in seasons, the shade of a tree, and all those things don't really come across well in flat images or photographs or things like that. A lot of the visceral experiences of being outside, things that you love, you know, the sun on your face or water splashing on your face, are a lot easier or much easier to feel when you're actually in the virtual reality environment. Next slide. So again, we design things and then present our ideas in the way of VR or public engagement meetings, like I said, like was mentioned before. So you can see these are some landscape architects in various meetings, situations, presenting to large crowds with a number of graphics, plans, sections, elevations, and things like that. And these meetings get buy-in from clients and then ultimately go to construction documentation. Next slide. So we prepare these drawings a little bit less colorful than the drawings previously shown in order to get builders and contractors out on site to actually put the things in place. You know, put a rock in one place like you see in the top left image, or lay out planting on a green roof that you see in the top right image. And for the most part, you'll never have to really pick up a shovel being a landscape architect. You'll be mostly responsible for the design and coordination process of getting things built, like the guy in that red circle in the top right. Next slide. So we do a lot, again, in terms of technology, of taking things from screens to reality. You know, again, huge rocks that would take so long to move in real life and get placed in the wrong place. You don't want to really make that mistake. So we'll mock up a lot of these rocks in 3D, color code them, give them numbers, and sort them out so that when the contractor, like you see in the bottom left picture, goes out to site, he knows exactly where to place that and only has to do it once. We do a lot of 3D modeling for custom benches and things like that, like you see in the top right corner. And then ultimately, all the technology that we use in the office helps get these things built faster and more efficiently, and make sure that they last forever. Next slide. And lastly, I'm going to touch on the organization that I represent, which is the American Society of Landscape Architects. And these are just some pictures from the national conference that we host every year, which is actually coming up this week. It's going to be on Thursday in San Diego. And the national conference is a great 4-day experience when landscape architects come together, share ideas. I'll be presenting this year on some VR work that I've been doing. And we generally just come together, talk about things that are happening in the world, things that we need to change, and how to become better designers overall. Landscape architects work with a number of different disciplines like traffic engineers, other engineers, architects, and things like that in order to build some of the best public projects in the world, and definitely in the United States. And I believe that's it. Thank you.
Very interesting. Great. Thank you, Andrew. Our final guest today is Diane Haithcock. She holds a Bachelor's of Science degree in Mechanical Engineering from Florida International University. Immediately after graduation in 1998, she began working at Underwriters Laboratories, Inc. Diane started in the Fire Protection Department as a project handler for various categories such as air ducts, wall coverings, and exhaust hoods for restaurants. In 2007, Ms. Haithcock became section manager of the Personal Protective Equipment Group. Since 2010, she has been the program manager of UL's standards technical panels, covering UL and ULC's standards for building materials, life safety, and security products. Diane, welcome.
Thank you so much for this opportunity to share with you the world of standards. As mentioned, I started out at UL fresh out of college with my mechanical engineering degree. And to be honest, I had never even heard of UL until a career fair in college. And my first thoughts were, wow, I could get paid to destroy things in the name of safety. Sign me up. Next slide. But we are not about destroying things. Our mission is to be an innovative standards developing organization that is making the world a safer, more secure, more sustainable place through leadership, collaboration, honesty, integrity, and transparency. Next slide. So why do standards matter? Innovation inherently creates risk. So when a new product is created, the world is often unaware of the dangers or risks that are associated with that new technology. Electricity is a great example of this concept. When first introduced at the World's Fair, electricity posed a major fire and electrocution hazard to buildings and attendees. But through science-based research, we began to understand that electricity, when handled and installed properly, greatly improves people's quality of life. Electricity's fire and electrocution risk were reduced through new safety standards. Can you imagine your life today without electricity? So standards, however, may reach beyond safety. They can help ensure that a smartphone effectively communicates with a smart appliance, or that a life-saving device like a PFD is intuitive for first-time users. Next slide. So over time, these safety procedures become built into the manufacturing process, and consumers, manufacturers, and retailers are left with the peace of mind that their product will operate correctly, effectively, and safely. So standards not only help make lives more efficient, but they also save them. Next slide. Safety standards are written documents that outline the process in which a product is tested to help mitigate risk, injury, or danger. UL standards cover more than just products, though. It also includes testing of systems and services. There's various engineering fields that are involved in the different stages, such as engineers are involved in the development of the standards, engineers are involved in the design of a product to meet the standards, and there's engineers involved in the installation of some products to be used. Next slide. So this image I actually took from the ANSI website. ANSI basically accredited standards developers so that they can develop standards in the United States. And in this slide, or in this picture, it shows how standards affect many aspects of an infrastructure. Next slide. So this slide lists the corresponding standards for each of the numbers of the previous slide. And my understanding, you guys will get a copy of this presentation so you can actually look at it in more detail. Next slide. There's also UL standards for products that you often see in your day-to-day, such as a standard for garage doors. So you might have noticed that garage doors used at homes are equipped with an inherent reversal system, which means that it causes the door to reverse if it hits an object during closing. And in January of 1993, it became mandatory for these garage door operators to also have a photo eye sensors or edge sensors or equivalent devices, which also causes the door to reverse. These change the way that automatic garage doors work and keep us safe. We also have standards for personal flotation devices, which are also known as PFDs. Hopefully, if you're ever on a boat or a ship, you see them. I also have standards for smoke alarms, for LED light bulbs, and mass notification systems. Next slide. And behind each of these products, there's various types of engineering involved. Even one product can involve various engineering perspectives. For example, smoke alarms could involve electrical engineering for the wiring connections, fire protection engineering for the sensors used to detect the smoke and the design of where to place them, the mechanical engineering for the interconnection with other alarms and other systems, computer engineering, as some use software analytics, and human factor engineering for the human interaction of changing the batteries and doing monthly testing to ensure that they still work. Next. So more about our process as a standards developer. We are accredited to develop standards in both the US and Canada. Next slide. And each standard has a committee of volunteers that are in charge of it. And they're called a Standards Technical Panel, or STP for short. The members can represent one of the following 8 categories, and we try to get a variety in order to get different perspectives. So each one could also have engineering perspectives. We also have a 1/3 balance rule so that there's no dominance from one of the groups. Next slide. Our process has 3 stages. It starts off when anyone, and I mean anyone, even one of you guys, can submit a change that they want to see in a standard. And we call this a proposal. The first stage is called preliminary review, where members or someone from the public can submit a comment about the proposal. The second stage is ballot, where the members vote, but anyone can submit a comment on the proposal. Assuming it reaches consensus, it goes to stage 3, and based upon the comments from ballot, the proposal can change. Stage 3 is when the members can look at those changes and then decide if they want to change their vote. Assuming it maintains consensus, then we publish the proposal into the standard. Next slide. And when members vote, they can vote as a yes, no, or abstain. And if they vote no, then they have to explain why they're voting no. Next slide. For us, consensus means that 2 conditions have to be met. Number 1, that a majority of the members submitted a vote. And number 2, of those votes, 2/3 have to be a yes or affirmative. Next slide. All right, some few more numbers. We have about 3,827 volunteers that are members of these committees that make up our STPs. And so far we have over 1,400 safety standards. Next slide. So you never know where a proposal can come from. There could be different engineering fields involved in a sort of a domino effect. So for example, at UL, they were exploring the differences between a room full of furniture from the 50s when everything was made of natural materials like cotton and wool, which is the house on the left. And on the right is a representation of a room with typical furniture you find today that's made of synthetic materials such as polyester and nylon. So a textile engineer would know that synthetic materials are more flammable. From a fire protection engineering perspective, we want to know the time difference for each room to get to a flashover condition if a lit candle is put on the couch. The results were that it took the room of natural materials room, the one on the left, about 30 minutes to get to flashover, where on the right, it took the room with synthetic material a little over 3 minutes. This is a very big deal when you think about how much time you have to escape your house. So this had us thinking about smoke alarms and wanting them to alert you as soon as possible to give you as much time to escape. You can find this video from the minute that the candle's lit to the flash over both rooms on YouTube, and the link is on the left. Next. So keep in mind that So the easy thing would be to make sure that smoke alarms are more sensitive and therefore alert you immediately. Without getting too technical though, smoke alarms have sensors to detect smoke signatures, and different materials have different smoke signatures. So we learned what the signatures are for synthetic materials. But as engineers, you have to look at multiple aspects. For example, the human factor. Unfortunately, when cooking, not fire, makes your smoke alarm go off, some people take the battery out to quiet it and then put it on their counter and forget to put it back. That's not the human behavior that we want, because smoke alarms don't work on your counter without a battery. So we knew that we didn't want the alarms to be too sensitive and going off every time a meal was being cooked. So we had to find the smoke signatures to represent cooking. All this ultimately led to new requirements in our smoke alarm standard. Next. So keep in mind that there are so many different types of engineering, and each play a very important role. So do a little research of each kind and see what piques your interest and what sounds fun to you. Next. On a personal level, I hope that you learn the importance of standards of safety. So when you go shopping, or even when you look around your home and you look at an electronic device or anything, I hope that you look for one of these marks on the product. And that means that the third-party company investigated a representative of that product to make sure that it met the requirements of a safety standard. Next. And I have a lot of background in fire protection, so for your future city project, keep in mind the following fire safety principles when designing a building or infrastructure. We need water to fight fires, so keep that in mind. Next. And that's it. Thank you again for your time.
Excellent. Thank you, Diane. Now is the time for our question and answer section. So if you have any questions for any of our three panelists, just type it into the question box now. Maggie, do we have any questions so far?
Yes, we've gotten a handful of great questions throughout. The first one, I think each of you might be able to touch on it a little bit. We had a question from Josie asking how your jobs help the fight against pollution. So I don't know who wants to take a stab at that first.
I can talk about that. So with the landscape architecture, a lot of what we do has to do with planting plants in general. So one of the things that trees do is sequester carbon. So what that means is that what a tree does, it will take carbon out of the atmosphere and then use that carbon to help the tree grow. So trees are just natural filters to the atmosphere and the air. So the more trees you plant, the more healthy the air will be. So landscape architects do a bunch of things that help the process of cleaning the environment and things like that. But just planting trees in general is a positive thing.
Great. Terrific.
This is Jennifer. I guess there's two different ways that transportation professionals can sort of help to combat pollution, right? So lots of people know that cars produce polluting gases, right, essentially. And so if we are able to limit the number of people that drive by promoting people to walk or bike, and the way that we do that as transportation professionals is we make sure that there's infrastructure for those options out there. It makes it very hard for people to choose to walk and bike when there's nothing for them to walk or bike on. So that's one way that we can do that. Another way is to help make sure that our roadways are not congested by making sure that they're running smoothly. When cars are idling, they pollute even more than when they're just moving along. So we try to make sure that everything's moving quickly. It's two different ways we fight pollution.
Great, thank you, Jen.
This is Diane, and from a standard standpoint, we actually have some documents in regards to sustainability, and they're not necessarily rules that everyone has to follow, but it almost gives them a ratings. And so as companies manufacture their products and how they manufacture them, the greener they are, the better rating that they get. So there are some ratings in regards to that. So everyone can always make an impact just even based upon what products you buy. So the more products that you buy that are safer for the environment or friendlier to the environment, then it encourages manufacturers to manufacture their products in that way.
Great. Thank you all. Kent had a question geared towards Andrew. He was interested in the kind of the rocks that you're talking about, and he wanted to know a little bit more about how and why rocks are important to the field of landscape architecture.
So rocks are pretty versatile. We can use them in a bunch of ways. Sometimes we use them as boulders to hold up grade, so using them as walls. Sometimes we use them as filtering mechanisms, so a lot of smaller rocks that we run water through in order to filter water. Sometimes we just use them because they're really nice. And we use them, as really nice placements to make a space feel a little bit more naturalistic or rustic. And lastly, sometimes we use them at the point in between water and land meet. So you'll see whenever you go out to a waterfront, typically on a large river or something like that, there's usually some large stones that help reduce erosion. So rocks are a good way to help reduce that as well. So a bunch of different things that we can use rocks for within the profession.
Great. We also had a couple questions, Diane, kind of geared towards standards. A lot of interest about different items such as 5G and then also LED lights, more so safety restrictions for the LED.
I'm not understanding the question.
So they just were wondering, are there standards yet? 5G is kind of still an emerging technology, I would say, kind of newer than, newest in that field, and kind of how are standards developed for that? And then also just safety, in using LED lights.
So there are standards in regards to LED lights, specifically depending on how it's used, we have different standards that cover LED lights. So if it's within a light bulb, we have a standard for that. If it's within embedded within another product, then we have standards for that. In regards to 5G, that's very interesting in that it's kind of a developing technology, and that is actually covered by telecommunications. So that's more by another standards developer, more by the government and the codes. But I do know in regards to fire, so first responders are actually trying to use 5G. It's called FirstNet, and that is going to be on the 5G network, and they are actually developing a one that would give for first responders first priority. But again, that's not necessarily 5G is where we cover it, but it is covered, just not by us.
Great, terrific. And we had a couple questions. As you might know, we have our student participants kind of do the things that engineers do and use the engineering design process as one of our guiding frameworks for Future City. And so we have a couple questions from students about kind of your use of the engineering design process, as an actual real life engineer. And some of the students are wondering, does the design process change based on what you are designing? And how many times do you have to go through it to get something perfect, if that even exists? So whoever wants to handle that one, feel free to jump in.
It's a really good question. I think for us, we always, like I said, as technology grows, we use technology a little bit more, but we always start out with a sketch. I think, the fastest thing to communicate what's going on in your brain is just to draw it. So for the most part, we usually start out with just quick sketches, and then from those sketches, we'll go to more detailed drawings, and then have meetings with either, clients directly or with the communities that we service, and we'll iterate that design or change that design time and time and time again. But what's important is that you kind of establish the objectives of the project in the beginning. So what are the main goals that, if the width of a path changes or you use a different rock, those things are still in the project. And ultimately, design might change all the way even during the process when it's getting built. You'll go out on site, and then, the guy building it will say, "Hey, Drew, we couldn't get the rocks that you specified. Can we use this other rock?" And then you have to change the design there and then, because you might want to meet deadline, or that second rock comes a little bit cheaper. You'll make decisions then, but the design changes all the way until it's actually finished. And if it's perfect, that's kind of up for other people to decide. That's why it's really nice doing public work, because we do a lot, in our heads, but then ultimately, if kids like yourself go out there and play and people use it, then it's perfect to us.
Great. Anyone else have anything to add? It's okay if not.
I would just add, don't be afraid to fail, and don't see it as failure, but see it as an opportunity to learn and grow, and always be open to input from others, because people always have different perspectives and different experiences. And I think that's what I really enjoy, and part of the standards process, in that I get to work with so many different people with different experiences and different perspectives, that it's amazing how much you learn, and they bring up things that you had no idea of or would have never thought of.
Cool. That's a great answer. Wonderful. We are getting some great comments about how inspiring each of you were, and you've really kind of ignited some interest from our young participants. So we have some questions about your suggestions on how to kind of pursue a career in engineering. Do you have any advice on kind of sticking with it through high school and college, and any particular fields you would recommend? I'm assuming each of you would recommend your field, but whatever you'd like to say about that would be appreciated.
This is Diane. And part of my presentation, I had that one slide with the engineering and engineering technology. I think the main thing is really do your research. You have internet research, but also don't be afraid to find a local company. So if you think you're interested in, saying, manufacturing of any type of product, see if there's one that's local to you. Call them up and ask them, "Hey, can I spend a day with you?" I think that type of exposure helps, but also doing your research on internet and kind of seeing of, okay, what does it really entail? How much education would I need? Some degrees, some careers you just need a bachelor's degree. Some careers you need a master's, and some you need I'm having a brain fart. Various degrees, you might need more than one, and you may need certifications. And so do your research and see if that really sparks any type of interest. And again, don't be afraid to reach out, call a company and ask them, "Hey, can I spend a day with you?"
That's
That's
great advice.
really going to be a great way to have an idea. But I think at the end of the day, it's not until you're really into it that you'll know. But the key is finding something that really sparks an interest in you, because at the end of the day, when you have a job, you spend a lot of time there. So hopefully you enjoy it.
Definitely. Great. Well, we also have an interesting question. Our participants are learning about engineering, but then also all of the other kind of science and tech and jobs that go into city design, like architecture, city design and planning, et cetera. And they're learning to also collaborate with each other. And so we had a question about kind of how you guys collaborate with other kind of sorts of folks within your kind of day-to-day job. So do you collaborate with architects, even though you're, working as a transportation engineer, Jennifer, and just to kind of make sure that everything is being designed well with everyone in mind?
Yeah, absolutely. So we have a lot of collaboration in my work as a transportation professional, and so just to give you an example, I am working on a traffic control plan. So I'm designing a work zone for a bridge construction project. And for that project, I'm working with structural engineers who are actually designing the bridge itself. I'm working with architects and landscape architects who are looking at the details of that. I'm working with some planners and lots of different people. And I think it's really important to remember that each of those different areas, specialty areas, brings something to the table that's really important. And I think having that collaboration is critical to ending up with the right project at the end of the day.
Certainly. Great. Does anyone else want to talk about collaboration?
Yeah, I would say we work with different disciplines on every project, unless it's a residential landscape that the house is already built. That's probably the only time that we'll be the only person on the project. But a lot of the projects that were in my presentation need a bunch of different heads at the table, and that's ultimately some of the best experiences because everyone brings their own specialties to the project, like Jennifer said. And we love collaborating with people because we know how to do our jobs well, but we let other people, get into the flow of their work and really do what they do well. And ultimately, what happens is sometimes there is what they call a prime, which is the person leading the project. And if we are the prime of the project, we will, of course, make sure that it's the best project for landscape architecture, but then also for all the other disciplines involved.
Great.
I guess one more quick follow-up thing on that collaboration question is I'll recommend to everybody, it's a really important skill to be able to communicate what you do to other people who maybe don't do what you do. And I think that's a really important part of collaboration is sort of building that skill, because sometimes it can be hard if the other people you're working with don't have the same experiences to communicate that to them, right? Why what you're arguing for is important. So I'd say to the students out there, make sure that you're continuing to build those skills and to work through it when it gets tough, because it's important to figure out how to communicate with others. That's a really important part of collaboration.
Definitely agreed. We have one final question. It has been a very popular question. A lot of our attendees want to know what your favorite parts of your job is from each of you, because it sounds really interesting, and obviously we're all learning a lot. But what makes you smile? What's your favorite part?
So I'll start first. So my favorite thing about my job is that I am designing for people. The work that I do has a direct impact on the lives of everybody out there. Everybody travels one way or another from A to B, from home to work, from home to school, whatever it may be. And it's very gratifying to see that positive impact when you put in the time and effort and to see it work out well.
Great.
This is
I
Diane.
would
For
say,
me, oh, I'm sorry, go ahead.
go ahead.
For me, I have two parts. Number one is being able to work with various people, the various interest groups. I work with firefighters. I work with various types of engineers, depending on what products we're trying to tackle in regards to safety, because they bring so many different perspectives. And number two is because I work with standards for safety, I have a pride in knowing that I'm saving lives without people even knowing, and that they don't even have to know. So I take a lot of pride in that.
Great.
Yeah, I would say I would echo what Jennifer said. It's really nice knowing that the things that you build or help build get used by people, and it brings joy. I think initially when I started out my career, I had like a big dream of designing a park and then going there and sitting there every day and just like watching people use it. And I still think about that all the time. It helps me in motivating me to continue my work. And then I think beyond that is kind of just again pioneering new technology. I love all the new tech that's coming out. It's a great time for technology. There's almost a new gadget every week, every year, and it's really good within the field to kind of learn that stuff and then be able to go and give presentations and have people be really responsive to that and bring it into their own offices as well.
Wonderful.
Thank you very much. Excellent questions, everybody. The Future City competition and webinars like this wouldn't be possible without the help of our final sponsors and partners. So I want to give a big thank you to Bechtel Corporation, Bentley Systems, NCEES, and Shell for their support. Also, a big thank you to our three panelists who took time out of their busy schedules to discuss their work with us today. If any of you think of any other questions or comments, or we didn't have time to get to your questions, feel free to email info@futurecity.org at any time. Also, please be sure to take the survey that will come up after the webinar is over. We always try to tailor future events to cover topics that you would like to see. So we really appreciate your honest feedback so we can continue to make these programs better and better each time. So thank you for joining us today. I learned a lot and I hope you did as well. Have a great day. Bye-bye.